In this video, we'll be conquering the most prolific C++ data structure of all time, the vector. Now, to access a vector, all you have to do is include vector like this, but chances are other files that you're including will also include vector, and to avoid defining vector multiple times, all you have to do is type pragma once, and this is a nice way of being safe and making sure nothing is included more than once. Now let's make an int main function, which will take no parameters, and within this function, let's make a vector. So vectors are in the standard namespace, so I have to type std vector and then specify the type. Let's have a vector of integers, and we'll call this vector v. Now, what even is this vector? Well, it's very similar to an array. So if I have an array of 10 items like this, and I'll initialize this array to have 10 ones in it, for instance. Now, this is the exact same thing as this. However, the vector is resizable and the array is not. If I wanted to add more than 10 items to this array, my only option would be to create a completely new array and copy all the data from the array into the new array and then get rid of the old one. And as a matter of fact, that's exactly what a vector does. A vector is just an abstraction on top of an array that allows it to be resized. When you run out of space, you will simply allocate more memory and then copy your data into this new memory block and free up the old memory. So most insertions will be constant runtime because you're simply adding one item. However, every now and then when you breach the capacity of your vector, you actually have to get new memory and then copy all your data into this new memory. And so it'll be linear runtime. However, the average case is constant runtime. So sometimes it only takes constant runtime to add something. Sometimes it takes linear runtime, but on average, it takes constant runtime. So to sum all of that up, a vector is slower than an array, but not too much slower. So let's initialize this vector to have 10 items in it. And now we have 10 items. Let's make each of those items 1. So now these are pretty much the same thing. The only difference is this vector is resizable. If I wanted to add something to the end of this vector, all I have to say is v.push back, and let's add another 1. Now, if I want to access something in the vector, it works the exact same as the array, where I can just say int I equals v of 0. There's another option where I could say int j equals v dot at 0. And these do the exact same thing, but the first option is far more common, and it's the way I recommend. I'll even show you another more obscure option. I could say int k equals v dot begin, which will get an iterator to the beginning of the vector, which is pretty much just a pointer to the beginning of the vector. So all I have to do is dereference this pointer to get the value. Now, if I want to get the value 1 past the beginning of the vector, I could simply add 1 to this, and just like that, you see how iterators are useful for accessing things, but the much more conventional way of getting the thing at index 1 would just be going like that. All right, now let's iterate through a vector. So the standard way of iterating through things is for int I equals 0, I is less than v dot size, I plus plus. And now I can do whatever I want with this index into the vector. If I want to print it out, I'll have to include IO stream, just like that. And now I have access to the std cout function, where I could cout the vector at this ith index, and then std and l to add a new line. Now, this is a perfectly fine way of iterating through a vector. However, a nice shortcut that it gives you, because it implements iteration, is I can just say for int I in v, and this is a shorthand for saying for each integer in the vector, I can type std cout I std and l, and these do the exact same thing, but as you can see, this is much nicer to read, much nicer to type, and this is what I recommend doing whenever you don't need access to the index. because this does not give you access to the index. It gives you access to the item, not the index. And if this vector did not contain integers, for instance, what if we had a vector of vectors? So I'll call this std vector of std vector of ints, and we'll call it v2d. So now I have a two-dimensional vector. And so this outer vector doesn't have such a trivial type. It's the thing that it's storing actually contains much more data. So what I have to do if I want to iterate through this is I can say v2d, so I'll say for std vector of int v in v2d. Now I'm iterating through each vector within this two-dimensional vector, but each time I'm calling this iteration, I'm actually taking a copy of the vector. And if I don't want to copy it, I'll have to type const here, and now my computer will know that I'm not actually going to be changing this, so it's safe to just give me a reference to the original vector. However, I can explicitly say, just give me a const reference to the original vector, and now I can avoid unnecessarily copying things. Now, this only works if I don't want to change what I have up here, and if I'm okay with just having a reference to it and not having my own copy of it. Okay, so let's get into some more methods that these vectors have. I could say v dot back to get the very last item, just like that. And as you can see, if I hover over this, this will just return the int at the very back. So I'll just assign this int I equals v dot back. What other methods do we have? Well, let's reverse a vector. We could type reverse. And now I don't have access to this reverse function unless I type std, because reverse is in the standard namespace. And reverse takes in a few parameters. An iterator to the beginning of the section that I want to reverse, and an iterator to the end of the section I want to reverse. So I could type v.begin, v.end, and great. Now I've reversed the entire vector. As you can see, I've typed std a lot of times in this main function, which can be a bit annoying. So let's using namespace std up here, and just by doing that, now in this entire document, I don't need to type std anymore. So what I can do is I can type Control H to pull up this find and replace, and I'll replace std with nothing. Now if I press Alt A, or I press this button over here, it'll get rid of every std : and everything works fine because we're using namespace std up here. I could also move this into the scope, and now everything within this scope has access to the namespace std. Or my third option is just typing namespace std and then defining my own scope, and everything within this scope that I've just defined has access to the std namespace. So these are all convenient ways of giving a chunk of code access to any sort of namespace, but you do have to be careful with this because this will include any names that are in your includes within this namespace. And if you want to use those names yourself, you're not going to be able to, because you've done what's called contaminating your namespace by adding other people's names into your namespace, and now you don't have access to those. So you do want to be careful with stuff like this if you want access to names that might be in the standard namespace. All right, let's get into some more vector functions. So if I type v dot, we have in place back, which will construct anything in the back of your vector. And this is different than pushback, because pushback takes in an object and pushes it into the back of your vector, or it copies it onto the back of your vector. But in placeback will actually construct it in that correct spot. So if I type in placeback string like this, well, this isn't actually going to work because our vector is a vector of ints, and I'm placing back a string. But the idea is, if this were a vector of strings, instead of constructing this temporary string and then copying it into the back of the vector, in placeback will actually construct the string already in the back of the vector and avoid a copy. This is a nice way of saving a few CPU cycles, and it really speeds things up if you're looking for performance, and most of us are. That's why we're using C++. So let's see what other things we have access to. We have this, let's see. There's a shrink to fit. So as I explained before, a vector is simply an array of memory, and the vector can resize to give you more memory, but it won't become smaller if you start removing things from the vector. So say you add a bunch of stuff. I'll say for int I equals 0, I is less than 100, I plus plus. So I'm going to add 100 numbers, v dot push back I, and then I'm going to remove 100 numbers. So I'll copy and paste this by just pressing Control D. I'm going to say v dot pop back. So I've just added 100 numbers and I've removed 100 numbers. The thing is, the vector got bigger when I did this, but it did not get smaller when I did this. Vectors don't shrink on their own, they only get bigger on their own. So if I don't want to keep all this extra data lying around, I have to say v dot shrink to fit. Now I'll get rid of the extra space that I wasn't using. And this is a sacrifice because this will take time to perform, but it will give you memory. So if you have a little bit of time to spare, but you want more memory, it's a good idea to shrink to fit after you remove a bunch of stuff from a vector. Another nice thing to know is a vector has a size. So I have this size method that returns the size of the vector, but it also has a capacity. So the size is the number of things that are actually in the vector, but the capacity is the amount of space that you have available. So your size might be 5 because you have 5 items in the vector, but if there's space for 10, the capacity will be 10. And so that distinction is important. Another nice method we have is v.empty, which will return true only if the vector is empty. And there's honestly a lot more that you could learn about vectors, but this is plenty to get you started. And if you enjoyed this video, please subscribe for more. Have a wonderful day. Adios.